I've actually done this.
You have?
No, I say that. It was like 6 months ago, and we got it halfway working. We knew that there was a couple cases that weren't.
Oh, cool. All right. Well, we're going to get it all the way working today, hopefully. So this one is capitalized words. Implement capitalized words type, which converts the first letter of each word of a string to uppercase and leaves the rest as is. So word is defined by thing that is at the very beginning or before a space, I think would be the...
Okay.
And this was made... Oh, I missed that. This was made by Anthony Fu himself, the creator of the challenges. Hey, Anthony. Cool. So... yeah, I think the first case is the easiest one, but yeah, let's, where would you dive in? We'll get back into this, and there's like an emoji in here or something, so.
Yeah. So we will definitely be recursing again, doing the string template literals, template string literals, whatever the word order is for those. Let's get going. So T, we want to extend string, and it's going to be inside a template literal. We are going to format as we go. We're going to grab word up until a break, whatever that's going to look like. Yes, thank you. Some kind of break. And then that gets followed by the rest, which we don't care. Actually, we don't need the rest then. We just need the what to anchor against. So break in this case, it's going to be just an empty space. Then this, and if we do extend, else I think we're going to end up with never. We will capitalize, and I don't know. I remember that. I think I remember TypeScript added a function for that. I don't know what it is.
Yeah. It's called. I think it's just called it's called capitalize.
That's nice and easy. We're going to capitalize our word. Oh, we need to return this in a string literal. And then I think that's the right syntax. And then we're going to, we need actually
to grab the rest.
We're going to grab for rest. We do need the break as well. I don't remember the syntax for that. Well, hold on. But we'll need rest. And this is going to be. I mean, in this case, this will work because it's hard coded to a string. But as soon as we get
to that point,
more than just that, we'll have to figure that out.
So, does capitalize convert the first character of string? Oh, okay, cool. So capitalize does the job. What happens? I guess I don't know what this part does. Let's see what we get up here. So it returns any. Do we have like an error somewhere? I don't think so. Okay, well, we have a lot of red things. So let's like type expected. Cannot find name infer. I think, I don't know if you can do.
You have it flipped around, right? It's infer ... word, isn't it?
No,
maybe not.
I don't think so, but why does it tell us infer? Cannot find name infer. Oh, is it because in a string it's okay. I don't think you do the dot is for so the spread thing is for arrays. All right. In the string literal world, it's a little different. So this will just get the first like the head here is just the first character. It has to be. That's the way that they made it work. And rest is the we could say tail, and a lot of times I use tail in the challenges. Rest is like the rest of it. So if we do this, let's just see what happens. Foobar. Okay, so I think I see where you're going with your solution. What if we take it like this? So if we take the first, the head and value, and then if we have, I'm gonna like comment this for a second. What if we take, if head extends capitalize head. So we need to check somehow that, did I spell capitalize right? C-A, here, you must have spelled it right. I didn't. Okay. So if head extends capitalized head, meaning it's already capitalized, then like we can go in, like, let's take notes here. Like head is already, I'm like, my brain is not letting me spell that word. Is that right? I don't know.
Looks right.
So it's already capitalized or not a letter. So, okay. If that is the case, let's just finish this one though. If we get to this point and we don't have anything left to grab, then we can just do, I'm gonna like put this in my clipboard so I can stop having to type it. We can just capitalize tail like that, right? So that makes sense, I hope. Oh, and then we
need to return head with that.
Right.
Yes.
So, so then from here, I think the next thing is if head extends capitalize head, meaning it's already been capitalized, then like head is not a letter, or so I guess I'm getting ahead of ourselves. We haven't talked about this up here. So a lot of the challenges work with maybe I led you astray by letting us do this break thing. So a lot of the previous, if you look through the code challenges solutions, the type challenges solutions, a lot of people do something like they'll do this and they'll do like you know, tab or whatever other things in here, new line. But really what the challenge is trying to get us to do is say, is it a letter? And there's a lot of ways to do is letter, but the hard one is like, how do you handle all of these other non-letter things, even like an emoji? Like you can't really make an exhaustive list. So the way to do that is here. The way to do that is to say, is the thing that we're currently this is only ever one character head. So is the because of the way TypeScript works, is this character equal to its capitalized counterpart? Well, that would be the case for, you know, exclamation point. Capitalized exclamation point is exclamation point, right? Capitalized emoji, crying face emoji or whatever is the same. So it's kind of like we're saying, you know, here, if we get to this point, head is not a letter. And so like, so capitalize the string before is going to be our goal. And like, head, oops, there's another, it doesn't really matter, but so like head is the previous so okay, so let's break it down. So we're gonna do, sorry that I'm like dominating the solution here, but hopefully it makes sense. Like does it make sense where we're headed at this moment anyway?
Yeah, it definitely does.
So like we're gonna take the tail, and then we can capitalize. Oh, why did I copy that? Okay, capitalize tail. Oops. Right, and then here we're gonna grab head and throw it in there. It's fine, and then capitalize words is like we're gonna recurse. Capitalize words. And then what we pass in is tail, because we've already handled the rest of the stuff. Like we've done our job here. So then we're gonna. Oh, I'm sorry. You know what we should do? We need the previous. I'm not thinking about it right. We need to store some values here for a previous value. That's what's happening. Equals this.
I don't think so. I think because each parent call of the recursion would do the assembling. So you just hand off whatever your child, that tail is, it gets processed and it hands it back.
Okay, yeah, let's try that.
Oh, except it's one, maybe. If it's one character at a time, though, right? You'd capitalize the F, you'd move on to the O.
Yeah, but how do we know that the previous character it was a space?
Right.
So I think that's really where it comes down to. So then this is going to be like this. Okay. So we have some temporary, and we need a comma there. We have some temporary storage that we're building in. So I think actually, is this right? Head capitalized. Okay, great. So here we go. Then if we get to this point here, then, you know, head is a caps letter. Then we can just pass in, we can just recurse capitalize words, tail, and then we can do previous and head as the second argument. Do we need a second argument? I don't think so. No, this is going to be good here. I don't think we don't need a second argument for that. Okay. So that's good. That handles that one. And then we have a syntax error. And these line up. These line up. Okay. Let's see what the problem is here. So tail, cannot find name tail. Oh, right. So this is before we were thinking about it. So if we get to this base case, all right. If we get to the base case of recursion, then we don't really have any letters left because there is no tail. So if head doesn't extend, if T doesn't extend head tail, that means there are no more characters. Well, if there are no more characters, then this is kind of like an accumulator. Let's rename this accumulator. So our accumulator is full. We can just return the value. And this is a funny trick because if we didn't capitalize here, then foobar won't work. Right? So we'll get everything else. We'll get all of the characters that we need. So like here, we have to capitalize the beginning of it. So that's what capitalize does. It capitalizes the first character.
Right.
So yeah, that's one solution. Okay, we kind of let me show you. Here's a couple more. So I always look around, like I said, in previous challenges for different solutions that I find, and here is another one. So let's just look at it. So uppercase letters. So this takes a different approach. It tries to split like uppercase letters by typing them out literally, which is a way to do it. There's a limited number of those, and there are unlimited number of delimiters. So makes sense to do. Head and tail. And then we have a temporary storage here as well. And we're seeing if it extends. In this case, we don't care about what we're capturing. So we just say string. And then we grab the remaining letters out. So if there are more letters to grab, then we continue recursing, passing them in. Otherwise, we can just capitalize this current character and put in the one before. And then at the end of it all, we return our accumulator, which is kind of similar to what we were doing above. Letters is defined as uppercase letters and lowercase of uppercase letters. So basically, that's how this thing works. Pretty clever solution. This is a union. So letters is a union of all the so it says uppercase letters if you hover over, and then all the lowercase ones. So it's kind of cool. All right, that's one. Any thoughts on that one?
It's neat how it just keeps consuming the letters and kind of just doesn't do the operation. And yeah. Like
the only place that actually does capitalize is like this one little section here.
Right. Yeah.
So this is another one. Can it fit on the screen? That's the challenge. Is letter. So capitalized words is coming in here. And then, we have this should transform thing is kind of interesting. So I don't think this is strictly necessary, but it is a kind of an interesting way to go about it because it's really clear what it's doing. So it's a Boolean, and should transform is set if the is letter function returns true. So is letter, here it is letter. So we're saying and this is very similar to what we did. Does uppercase, you could say, does T extend uppercase T? So like, let's see if we can get all the tests passed right now. T extends, this is very similar to what we did. It's very, and I think it maybe is arguably clearer one way or the other, but.
Nothing to comment wouldn't solve in our code.
Yeah, exactly. So
this one's interesting because of that should transform on line 78. Mm-hmm. One thing I've found myself doing a number of times with recursion in TypeScript is I have two functions. I like break out this like parent entry one that gets called by the application, and that it uses the actual recursion function. Mm-hmm. And I feel like that's what this should transform, because it does like just a slight variation on what happens if it's the entry versus recursion. So cool. I like that it's kind of handling it here in one method together.
Definitely. It is nice to do. And I've just recently learned, we had someone come on the challenges, and we did some like math oriented challenges, and they showed me some very, very interesting approaches where, they rewrote, like imagine we rewrote this whole thing, but in the generic constraints, and we just have equals result here at the end. So like we put all of this other stuff like inside the generic constraints here. And it was amazing. Like just stunning to see what you can accomplish with that approach. And yeah, there's a lot of ways to do this stuff. So that's another one. And then I wanted to show some nopes. It's not really fair to show these because the challenges change all the time, and I'm pretty sure that these used to work. But this one, I don't actually know why it fails, and so maybe someone can explain to me. So it fails on the emoji one. And so let's just take a quick look. We're lopping off characters. Fine, we've done that before. We're grabbing the head and just throwing it in there. And then we're doing capitalize rest. And we're seeing if head extends lowercase head. So this is our capitalization check. And then we're capitalizing. If not, we pass the tail. So this works. We get out of having to do another recursion level by doing capitalize at the end. So this is like an internal version, like capitalize rest is an internal version. And so we're grabbing the things out like that. It doesn't work for the emoji though.
I wonder if that's because emoji is a multi-byte.
Right.
Oh
yeah. Okay. Look at that.
String concatenation is forcing it to be byte by byte instead of like
you can't. Here, let me in the live share. You can't see this, but like, let me type. I just hovered over it, and this is what. Let me see if I can like word wrap. This is what it returns.
Look at that Unicode. Yep.
Yeah, that's an interesting point. Yeah, because emojis are multiple code points. Well, we're getting deep down into the dungeon here with TypeScript. This is the last one. It takes a different approach. This is wrong. I would say, although this passes, like this is
works on my machine.
Yeah, exactly works on my machine. It's a very brute force way to solve this problem, and is not in the spirit of what we're trying to accomplish. Because ultimately, like the point of the emoji one is to say like, don't handle it this way. Handle it by checking what a letter is. But I thought this was cute. I think this person was joking. There's no way to tell because it's the internet. But anywho, any other closing thoughts on this challenge?
No, I think this last one's more or less what my initial idea was in that approach, but because of the separator is endless.
Yeah, I should have told you. Sorry about that. I should have told you, like, we're not going to get by with just being able to specify the separator. And quite a few of the solutions online do it this way. And I think that's the reason why this case, C6 and A6 was introduced, is to force you to not solve it that way, which is probably better. But, oh well. Cool.